technology-based innovations for smart dairy. In recent years, dairy farming has seen significant advancements in technology and management practices. Technology-based innovations change the inputs the dairy farming system uses and reduces inefficiencies and improves animal health and welfare. These innovations include the use of heat recovery systems, precision livestock farming technology, and genetic management of the herd. Farms in this category also often decrease their reliance on soy, which is often used in feed given to cows. The goals of these innovations are to improve the efficiency of the dairy system and essentially make the same amount of milk with fewer inputs. By using fewer inputs, the carbon footprint of the milk decreases. The first technology is the heat recovery system. The milk from the cow is naturally at body temperature and needs to be cooled down to be stored and processed. These machines recover the heat produced in this process, and this heat can then be used for other activities on the farm. The farmer can use the heat to generate warm water to clean the milking area and the milking equipment.
And the benefit is in terms of energy efficiency again, because ultimately if I can use that heat that otherwise we would have dumped in the atmosphere, if we can use that to heat the water that's going into our boilers, it means we use less electricity. Again, that's good from a cost perspective, but also it's good from an environmental perspective.
In some farm systems, cows remain in barns and receive feed all year round. Soya is a common source of protein in dairy feed, but it is often imported from faraway countries and sometimes from deforested areas, and as such can have a significant carbon footprint. By reducing the inclusion of imported soya in feed and using alternative protein sources, such as a locally sourced legume, farmers can both save money but also reduce their environmental impact. Precision livestock farming technologies are technologies which monitor cattle and allow the farmer to respond more quickly using software which analyses the data immediately and provides timely, useful feedback to the farmer. The use of these technologies has revolutionised the way dairy farms are run, improving animal welfare but also efficiency and productivity. For example, early pedometers attach to the cow's leg and count the steps she takes. This allows the farmer to pinpoint the moment the cow is in heat and ready to breed, or if she has any locomotion issues. A newer technology are the accelerometers that can detect nuanced activity patterns. Using this information, the farmer can detect when a cow is ready to be bred and if she's feeding, moving and resting normally. A last example is the use of cameras, which allow the farmers to observe out of ordinary behaviour and detect early signs of disease and injury. Some of these sensors are even able to tell the farmer where in the barn each cow is.
All our cows have a collar, and round the collar is a large lump, and it's just like a Fitbit. Helps us to do two things. One is to know their welfare, because a happy cow is a cow that's eating all the time. And then secondly, we know from the activity that they have is whether they would need inseminating, and that's so they become pregnant so they can have another calf.
Genomic management in dairy systems uses DNA testing to evaluate the potential of young animals based on the genetic markers located in their DNA. Farmers can be interested in traits associated with milk production, such as fat content of milk or protein content, or the volume, or in traits regarding animal size or resilience of the animal. Genomic testing allows for a quick identification of these particular traits, and compared to the old way of selection where the farmer had to wait for the animals to grow and produce to show these traits, taking possibly years to know each animal's potential. Farmers could also be interested in fertility traits, like how easily the cows give birth, whether they can reduce the need for any C-sections, and by carefully selecting breeding stock, farmers can improve the overall fitness, health, productivity and profitability of their herd. Another important component of breeding management is the use of sex semen. Almost all dairy farmers use artificial insemination for breeding purposes instead of bulls. One reason for this is that keeping bulls on the farm can be dangerous, as they can get aggressive towards their keepers. Another reason is that when one uses artificial insemination, one can also select for female calves only. These female calves can then join the milking herd when born, while male calves cannot. Having the ability to select the sex of cows' calves increases the system efficiency.
That sex semen allows us to be more sustainable in terms of the least sustainable thing for anybody to do is produce something that the market doesn't want or need. and so we utilise that in our farming.